Greetings and welcome. In a previous video session of the module Fluid Kinematics, we have discussed about the types of flow based on the location of fluid and its boundary. So there are mainly two types, internal flow and external flow. In case of internal flow, the fluid is passing inside a boundary, closed boundary. For example, water flowing through a pipe. In case of external flow, the fluid is moving around the object, over the object. So that comes under the module external flow. So in this session, we will discuss about the flow around submerged bodies. Also, we will see the concept drag and lift. In order to understand the submerged body, let us take example. Here we see car is moving on the road, aeroplane is flying in the air, and submarine is moving under the seawater. In three cases here we see the object is passing through a fluid, or fluid is passing over the object. It may be either air or gas or liquid. In case of car and aeroplane, here the object is moving through the air, and in case of water, submarine is moving inside the water. So definition of submerged body is: a submerged body is an object completely surrounded by a fluid, that may be liquid or gas. Now, while moving this submerged body through a fluid, it is subjected to resistance offered by the fluid. For example, when we move in a water, we find somewhat difficult more than what we move in the air, because the resistance offered by the water. So this resistance offered by the fluid we will see in the form of force. So there are two types of forces, drag force and lift force. Here in this diagram we can see the application of these two forces. This is a body, it is called as airfoil. It is defined as a streamlined shape which is designed to produce lift more than the drag. Means what? As the shape of this body is a streamline, the resistance offered by the fluid is minimized, and that is why power consumption is reduced. So here on this body, the force which is shown here, this is a drag force, and this force is a lift force. Now this is a body, over this is a action of a wind which is flowing over this body. So with respect to action of this wind flow or direction of motion, these direction of force, drag force and lift force, the definition of these two are: we have seen that drag force, that is a component of force in the direction of flow, is along the direction of motion on a submerged body, is called drag force. It is denoted by letter FD. Lift force, the component of force which is normal, means perpendicular to the direction of flow on a submerged body, is called lift force, and it is mentioned with a letter FL. L and D are at the base. Mathematically, drag force is given by the formula FD is equal to CD into half rho A capital U square, and lift force is given by the formula FL is equal to CL into half rho A capital U square. The parameters of the formula are mentioned here. CD is a coefficient of drag, CL is a coefficient of lift. Rho is a density of a fluid, its unit is kilogram per meter cube. A is a projected area, means in this case the wind which is moving, it is striking to the frontal area. So this area is a projected area which is taken in a meter square. And U, capital U, that is the speed of the wind which is passing over this body, means speed of the air also. This is a relative velocity of the fluid with respect to the body, which is taken in meter per second. And drag force and lift force both are taken in a Newton. Now in the mathematical calculation here, this drag force and lift force, so its combined effect is taken into consideration with the help of this third force which is shown, that is called as resultant force. So this resultant force is calculated by the formula. So in this diagram we can say this is the resultant force which is calculated with the help of Pythagoras theorem. We will take this triangle into consideration. So this will be drag force component which is horizontal, and this lift force can be here, that is FL. So mathematically, by using Pythagoras theorem, this is a hypotenuse that is representing resultant force will be what? Summation of square of these two forces. So FR is given mathematically as in the square root sum of FL square plus FD square. Resultant force is also taken into Newton. Then direction of this resultant force with the horizontal or direction of motion is given by the angle theta. So from this diagram we will take this triangle into consideration. So in this triangle, if you take tan theta ratio, means what? Front side divided by adjacent side. So tan theta can be written as FL, front side, divided by adjacent side, FD. Further, theta can be calculated by taking the inverse of this, means theta is equal to tan inverse of FL by FD. This is about the direction of resultant force. Now, in the numerical, it is asked to calculate the power required to keep the body in motion. So, for that purpose, we take power is equal to formula. So, for that, we know that power is what? Product of force and velocity. So, here we take into consideration force, that is a drag force, and velocity that we take, that is a wind velocity or air velocity. In case of when the object is moving, then object velocity in meter per second. So Newton force and velocity meter per second, Newton meter per second, that is a product of power, that is further expressed as a watt. So this was the theoretical session on the topic submerged bodies, and also we have seen mathematical treatment for the drag and lift force and resultant force acting on the streamlined body, also angle of the resultant force with respect to direction of motion. Let us meet in the next video session. Thank you.